If I asked you to factor x squared minus x minus 6, we would look for two numbers that multiply to give us negative 6. Those same numbers need to add up to negative 1. That would be 2 and negative 3. So the factored form would be x plus 2, x minus 3 equals 0. Okay, I have the green parentheses and the blue parentheses. I'm going to multiply the green and the blue together and get an answer of 0. When you multiply two things together and you get 0 as an answer, what has to be true about one of those things? One of them has to be 0. So if x plus 2 was going to equal 0, what number plus 2 is 0? Negative 2. So one of our solutions is negative 2. If the blue part was 0, what number minus 3 is 0? Positive 3. Our solutions are negative 2 and positive 3. Now let's look at example B. This is a difference of two squares. X squared is the perfect square of x. 25 is the perfect square of 5. So this factors into x plus 5, x minus 5. If x plus 5 had to equal 0, x would be negative 5. If x minus 5 has to equal 0, x would be positive 5. Sometimes this answer is written as positive negative 5, just to cut down on how much you have to write. Okay, example A. This one's not a trinomial and it's not difference of two squares, so we have to go to greatest common factor. What do the two things have in common? X. Pull that x out, we'd be left with x plus 2. I'm going to go back to the green thing and the blue thing. The green thing times the blue thing is 0. That means that either the green thing equals 0 or the blue thing equals 0. If the green thing equals 0, what is x? 0. If the blue thing equals 0, x would be negative 2. If you don't have 0 on one side, you need to get one side to equal 0. It can be 0 equals or stuff equals 0. The other thing that you need to be aware of is that you really want your x squared term to be positive. Factoring when you have a negative in front is more complicated, so you want x squared to be positive. Let's start with example B. I want x squared to be positive, so I'm going to add x squared to both sides. You just have to be mindful of how you're rearranging the equation so you end up with 0 on one side and so that your x squared is a positive term. Now, on your own, factor that trinomial and solve. If you're watching the video, pause the video. So this would be negative 4 and negative 9. So x minus 4 times x minus 9 equals 0, which means our solutions are positive 4 and positive 9. How'd you do? All right, let's talk about C. What do we need to do first in example C? Minus 12 on both sides to get 2x squared plus 5x minus 12 equals 0. Problem, there's a 2 in front. Could we factor the 2 out? No, because there's a 5 in the middle. So we need to do the front times the back, the 2 times the negative 12. We're looking for two numbers that multiply to give us negative 24 and add up to 5. Anyone know what those numbers are? 1 times 24, 2 times 12, 3 times 8, 4 times 6. 1 times 24, 2 times 12, 3 times 8, 4 times 6. 1 times 24, 2 times 12, 3 times 8, 4 times 6. 1 times 24, 2 times 12, 3 times 8, 4 times 6. 1 times 24, 2 times 12, 3 times 8, 4 times 6. 1 times 24, 2 times 12, 3 times 8, 4 times 6. 1 times 24, 2 times 12, 3 times 8, 4 times 6. 1 times 24, 2 times 12, 3 times 8, 4 times 6. 1 times 24, 2 times 12, 3 times 8, 4 times 6. 1 times 24, 2 times 12, 3 times 8, 4 times 6. 1 times 24, 2 times 12, 3 times 8, 4 times 6. 1 times 24, 2 times 12, 3 times 8, 4 times 6. 1 times negative 3 times 8. Unfortunately, we can't just do x minus 3x plus 8 and be done with it because of this 2 in front. Instead, we have to write this as 4 terms, 2x squared minus 3x plus 8x minus 12, and then factor by grouping. Or you could factor by guess and check. If you need a reminder on how to do that, let me know. I'll help you out with factor by guess and check. In the first group, these two things, excuse me, have x in common. That would leave us with 2x minus 3. 8x and negative 12 have 4 in common. 8x divided by 4 is 2x. Negative 12 divided by 4 is negative 3. So the factored form is x plus 4, 2x minus 3 equals 0. Now, even if you think that you're just totally stellar at this, you need to pay attention to how to solve this one. The first part's easy. If x plus 4 has to equal 0, what does x equal? Negative 4. That's the easy one. If 2x plus 3 has to equal 0, we have to sit here and do 2x minus 3 equals 0 and solve that equation. So add 3 on both sides, divide both sides by 2, x equals 3 halves. Now some of you will start to pick up on the shortcut for this. You basically take the opposite of the negative 3 and then divide it by whatever number is in front of the x. So I can look at this and say, oh, the answer is going to be positive 3 halves. But until you kind of get used to that, it might be a little difficult to see that. All right, on example 3, we are going to do b only. What should we do in b? We got to get 0 on one side. We have two options. We can subtract 3x to the third on both sides, or we could subtract 15x squared and subtract 18x on both sides. Most of you like to be a little bit, like to do less work, maybe. That's how I'll say it. So a lot of you will likely subtract 3x to the third on both sides. So 0 equals negative 3x to the third plus 15x squared plus 18x. These three terms definitely have something in common. What do they have in common? They have 3 and x. But we really, really want this term to be positive. So even though they really only have 3x in common, we are going to pull out negative 3x. So this term divided by negative 3x would be positive x squared minus 5x minus 6. Okay, two numbers that multiply to give us negative 6 and add up to negative 5. That would be what is it? Positive 1 and negative 6. Yeah. Okay, this last step is kind of important because we factored out this negative 3x. One of our solutions is 0 because negative 3 times something has to give us 0. We have to consider negative 3x equals 0, x plus 1 equals 0, and x minus 6 equals 0. So anytime you have a monomial term in front like that, one of your solutions is 0. The other two are pretty easy. X equals negative 1, x equals 6. All right, example 4 we definitely need to look at. So let's look at example 4. There are 4 terms, which means we probably have to do factor by grouping. But before we do factor by grouping, do these 4 terms have anything in common? X. So let's pull an x out. We'll be left with x to the third plus x squared minus 4x minus 4. Okay, this x needs to save for later. Let's focus on the 4-termed polynomial inside the parentheses. We need to split that down the middle. What does the left side of that pink line have in common? X squared. And that would leave us with x plus 1. If we take x to the third divided by x squared, we get x. X squared divided by x squared is 1. On the right side, they have negative 4 in common. So our factored form is x squared minus 4, x plus 1. Don't forget, we have an x in front. Is this fully factored? These are my favorite kind of problems. I love these. They just keep going and going and going. It's like the Energizer Bunny. This part can be factored more into x plus 2, x minus 2. We still have the x in front. We still have the x plus 1. Now for all of our solutions. This part gives us x equals 0. This part gives us x equals negative 2, x equals positive 2, x equals negative 1. I prefer writing all 4 of them out separately, but you may see in the book or on like a multiple choice problem on a test, they could write this as x equals 0, positive and negative 2, and negative 1. So there are 4 numbers written here. They just collapsed that positive and negative 2 into one thing to save space. All right, for your assignment today, it was originally 10 problems. We are going to take out number 34, so you can do 32 and 36. You don't have to do 34. And we're going to take out number 52 at the end. That'll take it down to 8 problems.